Matrices have a rich variety of shapes, and each shape has its own unique purpose. As we mentioned before, a row vector can be seen as a matrix with one row, multiple columns, while a column vector is a matrix with one column and multiple rows. Any point on a plane can be written as a two-dimensional column vector. A point in three-dimensional space can be written as a three-dimensional column vector. In RGB space, a color vector can also be expressed as a column vector. In a data matrix, column vectors are often used to store data for a single feature. For example, in the iris dataset, each column vector represents one feature, like sepal length, sepal width, petal length, or petal width. In data analysis, row vectors are typically used to represent individual samples in the dataset. In iris dataset, each row corresponds to a record of one iris flower and can be written as a row vector. A rectangular matrix is simply a matrix where the number of rows and columns are not equal. For example, a tall matrix is one where the number of rows is much greater than the number of columns. Visually, it looks like a tall pillar. For instance, the iris dataset is a tall matrix. Tall matrices are often used to represent datasets where the number of samples is much larger than the number of features. Meanwhile, a wide matrix is the opposite. The number of columns is much greater than the number of rows. If you transpose a tall matrix, you get a wide matrix, vice versa. A square matrix has the same number of rows and columns. Many operations in linear algebra, like determinants, inverses, eigenvalue decompositions, are defined specifically for square matrices. If the transpose of a square matrix equals itself, then the matrix is called symmetric. In a symmetric matrix, the elements are mirror symmetric with respect to the main diagonal. In the diagonal matrix, all non-zero entries are on the main diagonal, and all off-diagonal elements must be zero. Diagonal matrices come in two types: diagonal square matrices and diagonal rectangular matrices. An identity matrix is a special kind of diagonal square matrix where all the diagonal entries are 1 and everything else is 0. Very soon we'll see the identity matrix appear in matrix multiplication, inverses, and orthonormal bases. Triangular matrices are another special type of square matrix. If all the entries below the main diagonal are 0, it is called an upper triangular matrix. If all the entries above the main diagonal are 0, it's called a lower triangular matrix. The transpose of an upper triangular matrix is a lower triangular matrix, and the other way around. If you're not quite satisfied with the shape of your matrix, you can actually chop it into smaller pieces. We can slice a big matrix into several smaller ones, almost like cutting tofu. Each small matrix is called a block or submatrix. For example, if you slice the matrix on the screen horizontally, matrix A gets divided into two submatrices. The block on the top is a diagonal square matrix, and the block below is a zero matrix.